Hey guys, welcome back to Quiz TV. Good to have you here. So let's focus on differentiation rule. We are still what Jamb mathematics class. So if you are going to write the upcoming Jamb and you are writing mathematics, understand that differentiation is one big part of the math syllabus in Jamb that you must cover very well. And differentiation is very wide. So we have done the first class on what general method, which is called formula method, right? So when I said if I ask something like y equals to what x, so we're going to do what dy over what dx. So when I ask something like this, a x equals to what n, is okay. So this is called monomial function. That is, it only have one here. It's okay. It only have one of it. So to differentiate from here, the formula method said that you're going to be dy over dx is going to be what a times n, right? It brings it down. Then you subtract one from the power here. It's okay. Because here we have what the index here. Now here we have the base, the coefficient, and the what and the index, right? So to differentiate it here, you bring one down here and multiply with what the coefficient here. Then subtract one from here. Do you understand? So this is called the formula what method. Just like if I ask something like this, y equals to 4x raised by what 6. Idea. So to differentiate from here is very easy. You're going to be what dy over what dx equals to what. Follow from here, bring one down here. Go. Now be what 4 times 6, right? X squared by what 6 minus 1, right? 4 times 24. So going to be what dy over what dx equals to what 24x. 6 minus 1 is what is 5. So you have differentiate for now. Do you understand? So this is called general what method or formula what method. It is likewise if you have for here, likewise if you have for here, y equals to 2x raised by 3 plus 4x2 plus 3. Now this is called polynomial function. So here you have to differentiate the one after the what order. You get. So that is, you want to differentiate this one the way you differentiate this one, right? You want to differentiate this one the way you differentiate this one. The same thing with this other one here, right? So going to be dy over what dx equals to what? This one here, multiply it here. 3 times 2 is what is 6x. Subtract 1. 3 minus 1 here we have what 2. Do you understand? So you have differentiated this one separately here. Plus the same thing here. 2 times 4 is what is 8x. 2 minus 1, here we have 1. So there's no point. Now this one is constant, you leave it. So this I what you differentiate what normal, monomial, and what polynomial. So now this now get tougher when you now have something like this. If you now have something like this, if you now have y equals to x plus 1 raised by what 4. Now this is where things get complex. Do you understand? This is where things get complex. So now this one is not like a regular stuff here. You have the inside, you don't have what a power here. Unlike we have 4s raised to power 3 is okay. Guys from here, you differentiate it. Now this is where chain rule comes in. Just that this is where I want to talk to you about here. So we are in this class here, we are looking at what chain rule. Looking at what chain rule, which is called function of a function. Right there, function of what of a function. Right there, and function of a function is called what chain rule. It's called chain rule. Chain rule. That's what we are actually focusing on this class. Like what I said, if I have something like this, y equals to what x plus 1 raised to what 2. Right there. Now we can easily what you can easily differentiate this one here when we expand it. You understand? Like this one, you can use general method to actually what solve this thing. You get, because if you have to x plus 1 always power 2, it's also the same thing as what x plus 1 when we expand it, right? So in our expansion, you have x plus 1, then plus 1 x plus 1. Do you understand? So when we expand it here, x times x is what s square, right? Plus x times 1 is what is x. Then you have done this one here, right? Let's look at this one here. 1 times x is what plus x plus 1. Do you see that? So which now going to be s square plus s plus x is what is 2x. 2 what x plus 1. Do you see that? So from here now, my y is now what? X squared plus 2x plus 1. I get. Now this one is a little bit easier because we can, if you have something like this, quite easily what expand it and get this one here, and this one you can easily what differentiate it. So dy over what dx is equal to what? 2x, right? Plus 2. Finish. It's very easy. Now things become more complex when you now have something like this. Maybe you now have 10. You now have what? 10. When we have 10, there's no way you can expand it, or it will give you tough time and you're going to waste your time. This is where the concept of what chain comes in. Concept of chain is you will use it to what when you have something like this, guess for what 5, 6, 7. So you cannot actually what a function you cannot easily what expand easily. So that's where the concept of what chain comes in. So you want to pay full attention because I'm going to break it down for you, and I'm also going to show you shortcuts to do this in here. So let's get into it. It's like now the chain method is what dy over what dx equals to what du over what dx times dy over what d what u. This is what is the concept. So how do we know du over dx and dy over what du? So please pay full attention here. So this where, if for example here we have y equals to what x plus 1 all raised to what 5. Now what we want to do here is that y is already equal to this one here, right? Now this one inside is called internal, and what we also have external. So this one inside will be defined by something else. So you now say let u equals to what x plus 1. In some table they use u, in some table they use what z. Depending on what they use, they are saying the same thing. Depending on what they use, they are all what saying the same thing here. So instead that we now have two functions, you now have y equals to x plus 1 is for what y. Now you now say let u equals to x plus 1. If u equals to x plus 1, that is, I can write this into be what y equals to what u raised by what 5. Is okay. So I now have u equals to x plus 1, and I have what y equals to what u raised by what 5. So I'm not going to differentiate it differently. So I'm not going to differentiate this guy here, right? So if I have something like this, u equals to x plus y, I'm not saying what du over what d what x, because I'm differentiating u in respect to what to x. Yeah, I'm differentiating y in respect to what to u. Do you understand? So du over dx is what? It's going to be 1. Du over dx is what? It's 1. You get, because if you differentiate from here, remember here is 1. Carry 1 here, right? If you carry 1 here, now it now become 1 minus 1. You're like you're differentiating x here. dy over dx. You're like you're differentiating 1. You're going to be what? 1 times x. This is 1 minus 1. You're going to be what? 1. So du over dx is what? Is 1. What about dy over du? So if you want to differentiate dy over du, dy over du, what do you have here? You're going to be what? 5 u. 5 minus 1 is what? Is 4. Can you see that? That is it. So if you want to differentiate it now, remember differentiation chain is what? Dy over dx equals to what? Du over dx times dy over what? Du. Right? So this is what I'm going to get. So my dy over what dx is what? Du over dx is what? Is 1 times. Now what is dy over du? My dy over du is what? 5u raised to what? 4. Can you see that? Now 1 times is also the same thing here. So you can just say dy over what dx is equal to what? 5u raised to what? 4. Now, but we're not going to live like this. We are not going to live like this. What are we going to do here? Remember, I said let u equals to x plus 1. So I will now replace u with what? X plus 1. So this is how it's going to look like. Let me use this add. So let it be dy over what dx equals to 5. My u is what? X plus 1. So let it be x plus 1, right? Raised by what? 4. This is not the word answer. This is what we call chain rule. Now we have to solve another question. Before I show you what, or before I review you the shortcuts. So let's try other ones here. So let's look at what these questions. So let's look at what let's check out these questions. How you can what able to what to differentiate them. You get and these are type of questions you likely see in your what Jamb examination. So look at the question. It says we should differentiate 1 plus 2x raised to 2 all raised to 4, right? And we should differentiate s raised to 3s raised to 2 plus 5 all raised to 4, right? And we should differentiate from what differentiate from. I believe by the time I finish solve these questions here, you should be able to understand the concept of what share rule. You understand? The other thing you want to do, I want to show you is what is shortcut. Remember, there's a shortcut formula which I will what show you by the end of this video. So that is why you want to stick to the end of this video. Shortcut. That one will help you to solve the share rule in less than 30 seconds if you can master it very well. Okay, now let's cover the first one here. Y equals to 1 plus 2x all raised to 2 then raised to 4. Now remember, for you to be able to differentiate it here, we now say let u equals to what 1 plus 2x raised to 2, right? So here you want to find, so if u is this, that is I can write the y expression to be what y equals to what u all raised to what 4, right? Now the y over the x, if you want to differentiate it here, this is what is chain rule, and we are using what dy over what dx equals to what is equals to du over what d what x times dy over what d what u. Now what do I mean here? You want to differentiate u in respect to what to x here, and I want to differentiate y in respect to what to u. Do you understand? So yeah, if you want to differentiate one here, if you want to differentiate du over what d what x. Now what will happen here? Remember, this one is 1, this one is 0, this one will go out, right? Because what is a constant. So this one is now going to be 4 times 2 times 2 is what is 4x. 2 minus 1 is what 1. So du over dx is what 4x. Now what about if you want to differentiate one here? We are differentiating y in respect to what to u, right? So now going to be dy over what du equals to what 4u, right? 4 minus 1. This is that. Now 4 minus 1, we should go to give what 3. So here we have what 3. Here we have what 3. Can you see that? So I've got what my du over the x, and I've got what my dy over what du, right? So what I want to do here to calculate what dy over the x, I just have to what multiply them. So I'm going to be dy over what dx equals to my du over the x is what 4x times my dy over d is what 4u3. Can you see that? So you find that you can multiply this one here. 4 times 4 is what? It's 16. So it's going to be what? 16x u raised to what? 3. Can you see that? Now, but remember, my u is what? My u is 1 plus 2s all raised to what? 2, right? So I will place it there. So it's going to be dy over what dx equals to 16x. Now because u is what 1 plus 2x 2, right? All raised to what 3. So here we have x. So this is what is the answer here. You understand? This is what. So let's just say this is what is the answer. Can see how easy it is. So it's not that too difficult. You have to take what step by step. So what I want to do now is this. So what I want you to do now is this. Pause the video and try and resolve this one for me. Differentiate this one here. Differentiate y in respect to what? In respect to x. So pause the video and try and evaluate this for me before you actually what continue. See how you can what solve it. But I believe you understand, so right? So pause the video and try it. I'll wait for you. Leave your answer in the comment section. Now let's look at what question 2. So if you look at question 2, y equals to 3x all raised to what 2 plus what 5 all raised to what 4, right? So in order to evaluate this thing here, remember here is 4. How do you evaluate this here? We now say let u equals to what 3x squared plus 5, right? So then this is called the inner. So if you want to write this here again, you got y equals to what u raised to what 4. Can you see that? So now let's differentiate the u. Let's differentiate the u over the x and what y over what y and what u. So in order to do that here, so the u over what the x will be what? Can you see down here? Going to be what? 2 times 6 is what? 6x. 2 minus 1 is what? Is 1. So they don't put the 1 here, right? Do you understand? Now let's differentiate this one here. They are going to be what? Du dy over what? D what? U, right? Equals to, going to be what? 4 times u 4 minus 1, right? 4 minus 1 is what? Is 3. So here you can just say 3. So we're going to be 4u3. Can you see that? Now remember, in chain rule here, we now have two different differentiation here, different what value here. Here we have du over the x, dy over what du. So dy over what dx is equal to what? Du over what dx times dy over what d what u. Can you see that? So what will now happen here? Dy over what dx is equal to what? Du over dx is what? 6 what x times, remember you are multiplying the here, right? What is dy over du? Dy over du is what? 4u raised to what? 3. Can you see that? So 6 times 4 is going to give you 24. So going to be 24x, right? So going to be so dy over ds equals to what? 24 what x, then u raised to what? 3 is okay. Now remember my u is what? What is my u? My u is what? 3x squared plus 5. So let's replace it there. So here we have dy over dx equals to what? 24x. My u is what? My u is 3x squared plus 5. Remember there's cube here, cube. That is what answer. As easy as that. It's not that too difficult, right? So look at this one here. Number 3. Let's look at number 3. Look at what number. So if you look at number 3 here, you have s squared minus 1 over x raised to 6. So you have y equals to, you have s squared minus 1 over what x all raised to what 6, right? So now in order for us this here, we have to what? Say u equals to what? S squared minus 1 over what x. Do you understand? So we have to differentiate separately here. Now, but what we want to do here is so what to write this one in what? In index form, right? You want to write, remember, we don't have 1 over what x. So this is s raised to minus 1 is okay. So we have to write like that. So it's going to be u equals to what? S squared minus s raised to minus 1. For we to be able to what? To differentiate this thing here, it's very important. So now whenever you have a function like this, it has to be like this in order for you to be able to what? To differentiate it. That's why you need to understand what is called the indices. So that's why you need to understand what indices. Do you understand? So that's why you need to understand what indices. So my u is equal to what? S squared minus s raised to minus 1 is okay. Now, what is our what will become our y? Our y is now going to be our u raised to what? 6, right? U raised to what? 6. So now this way we have to differentiate du over what? Dx. So let's differentiate du over what? Dx. So how do you differentiate du over dx here? It's still the normal regular pattern here. So let me just say du over what? Dx is equals to here. Here we have what? 2s raised to what? 1. Because x raised to 2, you also say that 2s raised to what? 2 minus 1, we're going to be 2x1. So that's what we have here. So, but how do we differentiate this one? Remember, there is a minus sign here, right? There is a minus sign here already. How do we differentiate this one here? So we have something like s raised to minus 1, right? So let me say y equals to s raised to minus 1. What are you going to get? Dy over ds equals to what? Guys, on that, so we're going to be minus 1, right? Times x minus 1. Remember, you subtract minus 1 here before minus 1, right? Just now, so we're going to be dy over ds equals to minus x minus 1 is what? Is minus what? 2. So when you differentiate this guy, you're going to have what? Minus x raised to minus 2, right? So we're going to have what? Minus s raised to minus what? 2. That is it. So when you open the brackets, what are you going to get? Minus times minus is what? It's plus. So here we have 2x plus x raised to the power minus what? 2. Therefore, my dy du over dx du over dx is what? 2x plus x raised to the power minus 2. Can you see that? So let me wipe this place out. So I'll wipe this place out again because I won't got this on here. Now, what are you going to do here? So you have got your du over what? Dx. Now, let's differentiate dy over what? Du. So remember, let me just drop this on here. So my y is equal to what? U raised to what? 6, right? So let's differentiate this one here. If you should differentiate it, here we have what? Dy over what? Du equals to what? 6u raised to what? 5, as easy as that. So I've gotten the two of them. Remember, dy over dx, dy or dx is equals to what? Du or dx times dy or d what? U, right? Dy over dx equals 2. So here we have this one here. Du over dx is what? Is 2x minus s 2x plus s raised to power 2, right? It's good you put in the bracket times. Here we have 6u raised to power what? 5. Yes, 6u raised to power what? 5. So what I want to do here is this, because this one is only bracket, so you just have to separate it like that. Let me write this place out. I have what? Dy over what? Dx equals to, here we have what? 2x plus s raised to the minus 2. Here we have times 6u raised to what? 5. Recall, my u is what? What is my u? My u is, what is my u again? It's like I wipe out u. Remember, my u is what? S squared minus 1 over s, right? This is what my u. So let's replace it here. So here we have dy or dx equals to, this one here we have 2x plus s raised to minus 2, right? Times 6. Where's my u? My u is what? S squared minus 1 over what? X raised to what? Raised to 5. That is it. So this is not what the answer here. So I want to leave you with this one here, the last one for you to try. You get, like what I promised you, I want to give you what? A shortcut method now for us to do it. But that shortcut is going to be in our next class. If you need the shortcut class, I can differentiate this one without you stressing yourself too much. Leave a comment section that you need the shortcut class. You get, if you need the shortcut class, leave a comment section that you need the shortcut class method for what? Chain rule. And I'll go ahead and produce it for you. I want to see the numbers of people who are actually interested. Thanks for watching. See you next video.